Hello again, and welcome to Pre-Calculus Trig, Section 3.2 on verifying trig identities. So in this section, we're going to learn how to do a type of proof called verifying an identity. When we do these proofs, we're going to utilize the fundamental trig identities, which are these. And we've used those quite extensively up until now. And the Pythagorean identities, which are these. So we're also familiar with these. So we're going to learn how to verify, or sometimes called prove, an identity. So we want to prove that the given equation is true for all values of the variable, where our variable is your angle. The thing that makes this a little bit foreign at first is that there's not an established method that works to prove all trig identities. But there are some established guidelines. So proving identities requires a trial and error approach, and sometimes a lot of erasing. You'll find that there are generally multiple valid paths, as long as all the steps are valid, that lead you to being able to prove a given identity. So not any two students are always going to do the same thing when it comes to proving identities. So once again, this is what makes this challenging at first, when you're not given basically a recipe and you're asked to come up with a proof. So our established guidelines for proving identities are these here. So you will only work on one side of the equation at a time. So if you work on the left-hand side, you won't touch the right-hand side. And the reason we do that is because we want to eventually get that left-hand side worked down and simplified so that it looks exactly like the right-hand side. And it doesn't necessarily mean you always have to start with the left-hand side. You could start with the right-hand side. But we don't touch the other side. Our goal in doing this proof is to transform one side to look like the other. And then we can conclude that you have an identity if you're able to accomplish this. So we choose the more complicated side to work with. And we wish to rework that more complicated side to turn it in to looking like the other side, and then we say we've proved our identity. So we use algebraic techniques to rework that one side. So those could be factoring, multiplying by the conjugate, any one of these operations here, distributing, finding a common denominator, and other valid algebraic techniques. But we won't be doing something like subtracting the same thing from both sides. We can't go over to that other side. That's an equation solving technique. So these are not necessarily going to be thought of as equations. They're identities. So we look for ways to substitute the fundamental identities with a goal in mind of making the side you're working on look like the other side, like we mentioned. Right, one of the techniques we can employ is converting all of the trig functions that you're faced with using to sines and cosines. This is not always necessary, but sometimes it's a useful approach. Right, so basically you want to try something. If you reach a dead end, you just erase and you start over with a different approach. So you're going to have to expect that you're going to reach some dead ends as you're learning how to do this. But every time you go through some approach, you get a little more insight into something that does or does not work to prove your identity. So we're going to start with this one, prove this trig identity. So I'm going to write it cotan x times the sine of x is equal to the cosine of x. All right, so I'm going to choose to work on my left-hand side because that's the more complicated side. And I drew a line down the middle to remind myself that nothing is going to cross over that line. So I'm going to convert the left-hand side to look like the right-hand side, and then I'll say, okay, I've proved this identity is true. So I'm going to use the technique, instead of writing cotangent of x, I'm going to say the cotangent of x is the same thing as the cosine of x over the sine of x. So I've done a substitution. And then I've got the sine of x. All right, now I'm going to do that multiplication. So that would be cosine of x times the sine of x in my numerator and sine of x times 1 in my denominator. Now I'm going to cancel out those sine of x right there, and I'll be left with cosine of x. So at this point, I've established that I have a cosine of x on the left, and I have a cosine of x on the right. So I've proven this identity. I've shown that by working on this left-hand side, I can get it to look like the right-hand side exactly. At this point, I can say it's proved. So this is how we're going to do it. And I might add, if you were asked to do this for a quiz or a test, all of this would have to be written out exactly like this. All of these steps have to be shown in a logical progression where your last step shows your left-hand side is equal to your right-hand side. And then you've proved the identity. All of this has to be shown. So I'm going to prove the identity 2 minus the sine squared minus the cosine squared is equal to 1. So I can see that the left-hand side is more complicated, so I'm going to start working on that side there. Now, whenever you see a sine squared of x and a cosine squared of x together, what you're going to think of is these Pythagorean identities. There might be a substitution that you can come up with to help you out with the proof. So I'm going to write it down here over to the side. This is actually not part of my progression in the proof here. So, but you can see it has a plus here, and I have a minus here. So what I'm going to do is I'm going to factor out the minus out of both of these two terms here. So I'm going to say 2, factoring out that minus will cause this to become plus, and also this to become plus. And I can look at that again, and I can say minus times this is yes, minus times this, that's also yes. All right, so there, what I can see it going on is that wherever I've got this, I can replace it with 1. So that's what I'm going to do. I'm going to say 2 minus 1. All right, so that looks promising because I'm trying to get a 1 here on the right-hand side, and now I can see that I'm almost there. So 2 minus 1 is 1. So now my bottom line, if I move that out of the way, should say 1 is equal to 1. So once it's down to the left-hand side equals the right-hand side, then you've done it. You've proved the identity. So all of these steps would have to be shown there in order for this to be a valid proof. And notice once again that nothing was changed on the right-hand side. In this particular one, all of my steps were on the left-hand side. All right, so this one's a little bit more involved. So I'm going to draw a line to remind myself that I cannot do anything on that right-hand side. So I'm going to attempt to transform this side to look like this when I get down to the last step. So I'm going to go ahead and I'm going to carry out this distributing here. So I can say that I have the cosine times the secant of x plus the cosine of x times the cosine of x times the cosecant squared of x. All right, so that's the cosine of x times the secant of x plus the cosine squared of x times the cosecant squared of x. So I carried out the distributing. Now when I look at this, I can see that I have a mixture of various things. I've got a secant, a cosine there, and a cosecant. So this is a good example of when you would want to change everything over to sines and cosines. So I've got cosines here. I can change the secant and I can change the cosecant squared. So if you do this many times, you're able to advance the proof along a little easier. So I'm going to go ahead and do that. So I've got the cosine of x times 1 over the cosine of x, substituting 1 over the cosine of x for the secant of x. And then I have the cosine squared of x. And then I've got 1 over the sine squared of x, which is the same thing as the cosecant squared of x. All right, so now I can go ahead and multiply these two together. I'll have the cosine of x over the cosine of x. And then I can multiply these two together, and I'll have the cosine squared of x divided by the sine squared of x. So now I can also see that that cosine divided by the cosine is a 1, and that the cosine squared of x over the sine squared of x is the cotangent squared of x. And I always want to keep in mind what my goal is. I'm trying to get this to equal to the cosine squared of x. Now I've got 1 plus the cotangent squared of x. Now this looks like a Pythagorean identity. Let's go back and look at that page for a second. So back on this page, you can see that we've got 1 plus the cotangent squared is equal to the cosecant squared of x. So we can perform a substitution using this. So this isn't part of my proof. It's over to the side, just as a reminder. So wherever you've got 1 plus the cotangent squared of x, you can substitute the cosecant squared of x. So here it is here. So I'm going to substitute for that the cosecant squared of x. Now if I look back to the beginning, I can see that I've completed my proof. So I'm going to write that down at the bottom here. So I've got on the right hand side cosecant squared of x, and also on the left hand side cosecant squared of x. So this one is proved.